Welcome to the fascinating journey through the life cycle of the Sun, a key component of our solar system. By the end of this lecture, you'll be able to describe the stages of a Sun-like star, explain why stars evolve, understand red giant formation, define planetary nebula, and explain white dwarf formation. Stars evolve as they consume nuclear fuel, leading to changes in core composition and internal pressure balance. This evolution is driven by changes in core fusion processes. Currently, the Sun is in its main sequence stage, characterized by stable hydrogen fusion in its core. At approximately 4.6 billion years old, the Sun is middle-aged, with a total lifetime of about 10 billion years. As hydrogen runs out over approximately 5 billion years, the core begins to contract, helium accumulates, and fusion stops temporarily. Gravity takes over, marking the Sun's middle age. The red giant phase begins as the Sun's outer layers expand enormously, surface temperature decreases, and luminosity increases. The Sun will transform into a red giant. During the red giant phase, Mercury and Venus are likely engulfed, while Earth may be severely heated, causing oceans to evaporate long before engulfment. Habitability becomes temporary. When the core temperature reaches about 100 million Kelvin, helium begins fusing into carbon in an event known as the helium flash, temporarily shifting the energy source. In the horizontal branch phase, helium fusion stabilizes temporarily, causing the star to slightly shrink. This phase is much shorter than the main sequence. As helium is exhausted, the Sun expands again and cools, becoming larger and brighter than before. Its ultimate fate is tied to its stellar mass. The Sun's outer layers are expelled as the core contracts, forming a beautiful nebula of gas and dust. The core remnant becomes a white dwarf, marking the end of the giant phase. If the Sun is like a low-medium mass star, its outer layers form a planetary nebula, and the core becomes a white dwarf, supported by electron pressure, with no nuclear fusion and a very long cooling time. Over immense timescales, the white dwarf will gradually radiate away heat, eventually reaching a cold, dark state known as a black dwarf, the endpoint for low-mass stars. The HR diagram illustrates the evolution track of Sun-like stars, from the main sequence to the red giant phase, horizontal branch, and finally to the white dwarf stage. In summary, the Sun maintains fusion on the main sequence for billions of years, enters the red giant phase as hydrogen runs out, forms a planetary nebula, and leaves behind a white dwarf.